Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about few problems on how to design NFAs. But before we start, a small information I'd like to share. In this channel, we produce every video in two different languages, Hindi as well as in English. And if you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. In our previous video, we have discussed about what is NFA, how to represent it, and how to see the acceptability of a string in NFA. In today's video, we are going to see some examples on NFA. We want to discuss many examples on how to design NFA. In this is the first part of the video. Design a NFA over A and B, the input symbols, such that the automata accept the string starting with A. So as we did in DFA, we need to find the strings that accept this particular language. So you can see the first symbol supposed to be A only, and after A, anything. So you can see the minimum string length that is accepted by this NFA is 1. One string length means one transition. And for one transition, the minimum number of states required is 2. So we are starting with a state Q0, which is a starting state, and with A transition goes to Q1, and on Q1 we can give as many A's or as many B's. So we can put a self loop over here. This is the NFA which accepts string starting with A. Unlike in DFA, we need not discuss anything about B in the starting state. Let us see the transition table. So Q0 is the starting state. On Q0, if we give the input symbol A, it goes to Q1. And on B, as it is not defined, we'll write here 5. Q1 is the final state. If input symbol A is given, it goes to Q1. And on B also, it goes to Q1. I hope you understood this. Let us do another example. Design an NFA over A and B such that the automata accept strings end with A. So let us try to find the strings accepted in this particular language. So we'll be having A, we'll be having AA, we'll be having BA. It means anything before the last A. So the minimum string length that is accepted by this NFA is 1. It means we need one transition. And for one transition, we need at least 2 states. For that, we can say Q0 is the starting state. On A, it goes to Q1. As it is saying, it is ending with AA, the A appeared. It means before that anything may appear. So we can put a self loop on A and B. Before the last A, anything may appear. And we need not discuss B on Q1. Let us see the transition table. If we are in the starting state Q0 and we give the input symbol A, we will be at state Q0 and Q1. You can see here on A it is going to Q0 as well as to Q1. Similarly, on Q0 if we give input symbol B, it goes to. On Q1 neither A nor B is discussed. So that's why we can say on state Q1 if we give input symbol A or input symbol B, it is 5. I hope you understood this example also. Let us discuss one more example. Design a NFA over 0 and 1 such that the automata accept string in which the second character from the left is 0. Let us see the string that are accepted in this particular language. Second character from the left. So the first character may be 1, the first character may be 0, but the second need to be 0. So it means first character can be 0 or 1. The second character will be 0, and after that anything may appear. So the minimum string length required is 2. And out of this 2, the second one is 0. String length 2 means 2 transitions, and for 2 transitions we need 3 states. So these are the 3 states. The first transition will be taken. The first transition is over 0 and 1. Anything is okay, but the second transition need to be 0. Now after 0 appeared, anything is okay for me. So I can give a self loop on Q2 with 0 and 1. So this is the required NFA. So let us see its transition table. On Q0, if we'll give 0 input or 1 input, it goes to Q1 only. On Q1, if we'll give 0 input, it's supposed to go to Q2, and for 1 input it is not defined. So that's why we'll say it is 5. Q2 is the final state. On 0 and 1, it goes to Q2 only. So this is the NFA for this particular language. Let us do one more problem. Design a NFA over 0 and 1 such that the automata accepts string in which the second character from the right is 0. So let us discuss a string which is accepted by this particular language. So second character from the right. The minimum string length is 2. The second character is 0 and the last character, it may be 0 or 1. And before this 0, it can be anything. So anything, then 0, and lastly we'll have either 0 or 1. So the minimum string length is 2, and for 2 transition we need 3 states, and we can design it in this way. This is the accepted state, and to come to this particular state we'll be having a transition 0 or 1. This is string length 1. And to come to Q1 we'll be having one more transition. This transition is last but 1, or we can say second from right. And before that anything may appear, so that's why we can put any number of zeros or any number of ones for this particular NFA. And we can have the transition table also. Q0 is the starting state. On input symbol 0, it can go to Q0 as well as to Q1. Similarly, if we'll give input symbol 1 on Q0, it goes to Q0 only. Now let us assume for state Q1. On Q1, we give any input symbol 0 or 1, it goes to Q2. And on Q2, neither 0 nor 1 is defined. That's why we'll write here 5. I hope you understood this NFA also. Let us discuss one more problem. Design an NFA over 0 and 1 such that the automata accepts string length exactly 2. Q0 is the starting state. On 0 and 1 you can come to Q1, and again on 0 and 1 you can come to Q2, which is the final state. So this is the NFA. Q0 is the starting state. On 0 or 1 we came to Q1. Again on 0 or 1 we came to Q2. And Q2 is the final state. Neither at Q0 nor at Q1 and nor at Q2 we cannot give any kind of loop or any other thing here, because it is saying string length exactly 2. So we need 2 transitions only. I expect you to draw the transition table for this NFA. Let us design a NFA over 0 and 1 such that the automata accepts string length at most 2. We'll be having a NFA, its maximum length is 2. It's supposed to accept any string of length 0 or 1 or 2, but not more than 2. So this is also very easy. We'll take the starting state as final state, the first state Q1 as final state, and Q2 also as final state. And on each of these states, we are defining a transition over 0 and 1, because we are saying at most 2. I want you to draw the transition table for this NFA also. Let us discuss one more example. Design a NFA over 0 and 1 such that the automata accepts string length at least 2. So the minimum length it should accept is 2. So minimum string length will take 2, and after that anything may appear. So you can realize this problem also. Q0 is the starting state. On 0 or 1 it will go to Q1, and again on 0 and 1 it is going to Q2. So this NFA already we have seen, which is having exactly string length 2, and we are saying at least 2. So it means after that any number of 0 and 1 may appear. So this is the required NFA that is having string length at least 2. Please draw the transition table for this problem also. Let us do one more problem. Design a NFA over A and B such that the automata in which the number of A's are not multiple of 3. We have to use here the operations that we have discussed for DFAs. So let us try to first find the strings having multiple of 3 A's. So we can have epsilon, we can have 3 A's, we can have 6 A's, and so on. So the NFA for this particular string is, we are starting with Q0, 0 number of A's also accepted, or we will be having 1, 2 and 3 number of A's. So as many times 3 number of A's appears, it will be accepted. Now this is not our problem. Our problem is number of A's should not be multiple of 3. So what we will be doing? We will take its complement. So the problem is asked about the complement of this particular problem. When we take the complement of this problem, it will look like this. As we have already discussed under DFA operation, in order to make complement, the final state become non-final state and the non-final state become final state. In order to do the complement of this particular problem, then the NFA will be like this. Q0 is the starting state. On A, it is going to Q1. It is an acceptable state. On again A, it is going to Q2. Again, it is an acceptable state. On again A, it is going to Q1. It is not acceptable state. You can see here, this NFA will accept either 1 or 2 number of A's, but not 3 number of A's. I hope you understood these problems. Today we have discussed 8 problems on how to design NFAs. If you understood the video, give a like and share among your friends. If you have any problem, do comment me in the comment section. In our next video, we are going to take some more NFAs. Till then, take care. Bye.